Okay, volumes. We will look at volumes in 12D and how they're calculated. So just on the screen at the moment, there's two methods. There's tin and a height. So basically using your surface and then picking a base RL to draw from. And the methodology we'll look at today is the between two tins. So using two tins to create a volume, and two methods of calculating that one, which we'll be looking at end area and exact. So let's get stuck into end area, tin to tin first. Actually, before I get cracking into this, I should note that the method of calculation is depending on your data set. So between these two, for the data I'm going to be using, so this data follows a super alignment. So the way the end area works, it creates sections at a set angle. So I'm more inclined to, if I wanted this to be accurate, as most accurate as possible, to use exact volume between tins method, as that uses a triangle calculation, tin to tin method. So, but for now we'll have a look at both and then we'll compare the differences. So I've just chucked on my 2D pavement types, and I'm going to be comparing my feature survey to my design surface I've created in a previous video. And let us run with the changes in these two surfaces where they intersect pavement type 7. Actually, let's start with the exact volume between two tins, and then we can compare with the end area calculation. So let's select our feature survey, our new tin. Now range file, we can go over and have a look in 12D's set ranges. So this file will help you understand at different depths of differences, and give you kind of like a more accurate cut to fill value at what depths the two differences are. So if we select, let's see what we've got to use a library. Oh, we've got even some more accurate ones. Cool. So another instance where we could use this as well is if you've got a slab, or like a massive concrete slab or something like that, and you want to run a volume of difference between the two. Someone has kindly had done the work beforehand and created a interval range of 1mm and 5mm, and we can actually create a heat map over our tin to visually see the differences on the surface. And let's have a look at this as well. So let's just chuck on one of their preset ones from 12D. Let's just go 100mm interval difference. Now, model for faces. So this is the model where this range file will paint. So let's just create a model called heat map for now. Heat map, feature survey versus design surface. Enter, and I'll just select the view where I want that model to come and paint. And then we want to clean our faces before. So if we're re-rolling this volume for various reasons, we want to clean this so it cleans so we're not just duplicating up points or filling up the report unless you want to. Okay, now we'll use the polygon to define the calculation. We'll use our pavement type. So the area where the feature survey and the design will overlap this pavement type is where I want to calculate. So anything out here is not going to be calculated unless I use many polygons. And report file, so I'm jumping the gun here. So report file, I'm just going to call this today's date, feature survey, feature versus design, surface type 7 area. Cool, now I will calculate, and because of my okay, so we have a value. So before actually going into this report, I just want to go over, there's something, oh, where did that heat map go? Let's bring it back. So something to keep in mind, the interval range, if your values of your tins are beyond this range, it will actually not put it in the calculation, so keep that in mind. So let's just double check this interval file, and so I definitely know there's not, okay, sweet. So I definitely know there's not going to be a height difference of 300 meters between these two tins. So it's kind of well covered me just in case if there's like anything greater than a 3 meter height difference. So we can also see, okay, our fill values are above 0, and it's green to dark to blue to light blue, and vice versa for cut values. And also you can this is a if you open this back up again, this is where you can see how we can edit our own interval values in here as well, and writing them out. Okay, so we'll have a look. Apologies because of this tin, a lot of triangles to calculate from. It's picked up that that nulling we've done in a previous our tin nulling video. So that's something to keep in mind too, to making sure you're using the correct tin for your calc. So it's a bit hard to see if there's anything else that's more than 100 mil. So let's just change this and chuck it on. Let's go 50 mil. Enter. Clean faces on. We'll hit volume and replace. Let's close that report down. Okay, so apologies if you're using my mock data with this tin, it takes a while to load. Okay, let's have a look at our report. So exact volumes between tins will give you a depth analysis. So at the listed depths based on your interval range file, we can see the cuts and fills at those depths. So if we go down to the differences of, so 300 mil below, we have our cut values and our fill values. So this is handy information for the engineers to see where they're going to be doing most of their digging or most of their filling. Let's look at our results. We have a total excess or balance of 607 cube with a 5 cube cut and a 612 cube fill. So, and we can visually see that in our heat map. Yes, there's bugger all cut indicated by the red fill, and so red hatching, and then majority green and blue for the fill or close to 0. And as another double check, let's go to our 3-dimensional view. Get this guy to stop. Oish. Okay, and if I've just got my 2 tins on in my 3-dimensional view, I can verify, yes, okay, so majority of it is a fill value. Now let's go through our other method. Okay, I'm just going to get rid of this heat map so it's not lagging me out. Now let's run our end area volume, and we'll just minus this for now. Okay. So original tin, feature survey, new tin, our design, and angles for sections. So this value is going to show you how the where it's going to create sections at what angle that you say. So if it's at 90 degrees, it's going to be from north to south all the way through our job. So which is why I preferred exact volumes for this method, because this is a super alignment going on a changing angle. 90 degrees up and down, north to south, may not exactly represent the differences between each surface. But let's have a look and see the comparison. And here we can also set the distance between the sections too, so that will also heavily influence the accuracy of the area calculation. So currently they're set at 10 meters. Let's just keep it at that, and then we can change this and see the differences as well. Original tin sections, so I'm just going to keep this as okay, and these will be our sections that will cut across our areas. So original sections, we'll call this cross sections. Our design, civil. Okay, let's just copy this. Oh, sorry, wrong one. This is our new. This is our original, and then this is our difference. Difference color. Let's make it cyan, a bit more visible. We won't use extrapolated areas for this one. We will clean our models beforehand, and then select the governing polygon. Report file. Let's call this one, yeah, feature versus design end area calculation. I'll override the one I've done before. Report mode, we'll leave this one, and average end area, we'll leave that too. And we'll hit volume. Replace. Groovy. Now let's compare results. And for reference too, we can see how this method has done the calculation. So if we chuck on our cross sections, and then so we can see the difference as well in our surfaces at this cross section. So being it at 10 meters of distance, we can see our balance is different to our exact. Looks like it's a bit on the larger side with more fill. Based on this method of calculation. So, and let's just see for reference if we shorten these, and it's also at 90 degrees as well, cuts. So let's shorten these up and then see if we get a closer result. We hit volume, replace. It's updated our sections as well, and we can see we're getting closer to our exact method. And that's pretty close now too. Cool.